finally done. Alright, we need to celebrate.
Alright.
Try some of this Gatorade.
Okay. Hello?
Christian, where are you? Video project's due in 20 minutes, and you have the flash drive. Where are you?
What day is it?
It's Wednesday, Christian. Where are you?
Oh!
Good morning, Christian.
Not anymore!
There's no time! God. Ugh. Ah. I'm almost there!
So, we originally planned on doing our video project on building a Van de Graaff generator, but we couldn't build it. We had everything going, we had moving
Christian's
belts,
fault.
and it just didn't work. It was mostly Chris's, mostly Will's fault. But, so, our new idea, go-karts.
So what we're going to do now is find the acceleration of my go-kart. First, we've measured time, displacement, and we know velocity initial is 0. So once we have the acceleration, then we can find the mass by weighing it, and we can also find the force at the bottom of the wheel by multiplying those together. Once we have the force, we'll have the distance from the lever arm, which will be the radius of the wheel, and that will give us our torque.
So right here we're going to use a motion equation to find out the acceleration of the go-kart. And from the video that you've seen with Christian riding in the go-kart, we know that the V naught, or the V initial, is 0. And we calculated with meter sticks that the distance he traveled was 100 meters, and it took him 7.9 seconds. And we plugged that into our equation, and we got that acceleration equals 3.2 meters per second squared. After we found that, we used this to solve our force. We did F equals ma and plugged in our mass, which we found earlier, and the acceleration to find a force of 576 newtons.
53.8.
53.8 pounds.
$57.4.
57.4 pounds.
So we just add all these guys together and then we have the weight of the go-kart?
Oh, and then we have to add Christian's.
Yeah.
70.8.
70.8 pounds.
Woo! Last one.
45.9 pounds.
Equally distributed.
Wait, can you redo that one? How is that 40? Oh, I guess the engine's over there.
There you weigh yourself, Fatso.
And with the helmet.
312 pounds.
Gearing up. Shane, can you please step out of the screen?
Oh, yes, please.
There you go.
Yes.
This is really good lighting. I like this natural light. Brings out the colors.
Still reading.
Christian, it's okay.
185.9 pounds.
Okay.
So right here we found the total weight, and the weight in the x is negligible because the theta is so small. Right here we have the wheel 1, wheel 2, wheel 3, wheel 4, and all the weights, and then the weight of Christian. And then we have our total weight right here.
On that note.
So this is just a quick explanation of what was happening while we were weighing our go-kart. So, because the scale obviously has a height, whatever wheel we were weighing was slightly higher than the others. This causes a slight angle between what we're weighing and where the rest of the cart sits. So, what we see here is, suppose this wheel is being weighed, it's slightly higher than the others, which is going to make the force of normal, which is the directly vertical line with the go-kart, is going to go slightly to the right, and there's going to be a small angle right there, which means that the force of weight is going to be only a component. The force of weight that we measured is only a component of what the true force of weight was. So here's a larger scale. This is the force of weight, this is the true force of weight, and that's going to be this hypotenuse, and the force of weight of the scale is what we measured, and then there's a small force of weight in the x going to the left, which is going to be what's going to change our calculation.
So we calculated the combined weight of Christian and the go-kart, and that came out to be 413.8 pounds. And we used a conversion factor of 0.453 kilograms to 1 pound, and we got the mass of Christian plus the go-kart to be 180 kilograms. Okay, torque equals force times the lever arm times sine of theta. This is how much force you're applying. The lever arm is the distance from the pivot point, and sine of theta, where theta is the angle between the lever arm and the force.
Okay, so now we're finding the torque of the wheel, and pretty much we're going to use the equation torque equals Fr sine theta. F is the force, and then R is the lever arm, and then sine of theta, which will equal out to 1 because theta is 90. The force required is 576 newtons, and the R is, what is it, Shane? 11.5 centimeters, so 0.115 meters. Okay, so we're going to plug it into the equation here. And that equals 66.24 Newton meters. So, we just found the torque of this wheel, and since it is on the same axle as the sprocket here, we know that the torques are the same. And that torque is 66.25 Newton meters. Then, to find the torque of the clutch here, we can use a ratio doing torque of the sprocket over teeth of the sprocket equals torque of the clutch over teeth of the clutch. And we got the teeth to be 58 and 13, which you can see the teeth here. And inside the engine you can see teeth if you want to get all in there. Doing cross multiplying, we get the torque of the clutch to equal 14.85 Newton meters.
No, Christian, no! Chris, you saved me.
Sadness is tolerated when Mr. Willard's gone. See all the smiles in the class? I wonder why. Look at that. Wait, Mr. Willard came back in the room.
Wait, I'm crying.
Why are you crying? Look at that. People just leaving. People leaving with free will. What? Oh my goodness. Is he standing before the bell? What? Look at that hood. Look at that hood. Look at that hood.
Captain, my captain.
Wow, look at all the danger in this classroom right now. We are just neglecting it. And look, there's Lizzie, just shocked by it all. And there's our substitute. Say hi to Mr. Willard. It's a video for him. There are some people that stay productive. These are my friends.
Wait, Christian. There's no.
Okay.
No, wait. Don't finish it.
I'll see you tomorrow, Mr.
No,
Willard.
don't.
Oh.
So we definitely just got the cops called on us for driving go-karts around. So we're about to leave real fast. Oh, here's my ride. Let's go. Didn't we just get the cops called on us?
Yeah.
Yeah.
I'll give up.
God damn it, Chris, come on.